Welcome to The Explainer. Today, we're going to break things down to their absolute core. We are talking about factorization, a concept that, believe it or not, powers so much more of our world than you'd ever think, connecting things you'd never, ever expect.
So what do secret codes, financial planning, and architectural design all have in common? I know, it sounds like the beginning of a bad joke, right? But the answer isn't a punchline. It's actually a fundamental mathematical idea. The one thread that weaves through all of these super high-stakes fields is the power of factoring.
So at its heart, factorization is just about deconstruction. It's kind of like taking a really complex machine apart, piece by piece, just to see the gears and levers that make it tick. When you understand the components, you finally understand the whole thing.
Okay, so here's our blueprint for today. We're going to start with the DNA of numbers themselves, then we'll build up an algebraic toolkit, and finally we'll see how this whole concept actually constructs the world around us. All right, let's start at the very beginning, with what I like to call the atoms of the number world. These are the prime numbers, the indivisible fundamental building blocks that create everything else. So what exactly is a prime number? Well, think of numbers like 2, 3, 5, 7, 11. You get the idea. The only way to get them is by multiplying one by themselves. That's it. They can't be broken down any further. They're these pure, fundamental units, and every other whole number is actually built from them.
And this process shows us how we can methodically break any number down into its unique prime factors. Okay, so take a number like 7007. We start by finding the smallest prime that can divide into it. In this case, it's 7. That leaves us with 1001. We just do it again. Turns out, 1001 is also divisible by 7, which gives us 143. Okay, what's next? 143 is divisible by the next prime, 11, and that leaves us with 13. And since 13 is itself a prime number, we stop. And there it is. The prime DNA of 7007 is 7 times 7 times 11 times 13.
And look, this isn't just some neat party trick. This concept is so important, it's called the fundamental theorem of arithmetic. It means every single number has its own unique prime factorization, like a one-of-a-kind fingerprint. No two numbers share the same one.
And this, right here, is our first big connection back to that riddle. That unique prime fingerprint is pretty easy to figure out one way, multiplying primes together. But trying to reverse it for massive numbers, it's incredibly difficult. And that difficulty, that's the entire foundation of modern cryptography. Just hold that thought for a minute.
Okay, so now let's level up. We're going to see how this idea expands from just simple numbers into the whole world of algebra. It's time to assemble a toolkit for factoring more complex expressions.
The most basic tool in our kit is simply finding what's common. So if you look at the expression 3x plus 9, you can see that both parts share a factor of 3. By pulling that 3 out front, we reveal the underlying structure, 3 multiplied by the quantity x plus 3. Simple, right?
All right, next up we have factoring by grouping. Now, an expression like 2xy plus 3x plus 2y plus 3 might look a little messy at first, but the trick is to just group terms that share factors. So, let's pair up the first two and the last two. From that first pair, we can pull out an x, and that leaves us with 2y plus 3. From the second pair, we can pull out a 1, which also leaves us with 2y plus 3. And just like that, a brand new common factor is revealed, 2y plus 3, and we get our final, clean, factored form. And then you've got these are like the power-ups, the shortcuts, they're called identities. You should really commit these to memory, but the most famous one is that difference of squares right at the top. Anytime you see something squared minus something else squared, you know it instantly factors into a minus b times a plus b. Seriously, recognizing these patterns is a huge time saver.
Okay, for all you visual learners out there, you are going to love this next one. It basically turns factoring a complicated-looking expression into a simple little puzzle. Let's check out the box method.
So here's the secret sauce for the box method. We want to turn our 3 terms into 4, so they fit neatly in the box. We take our expression, 2x squared plus 11x minus 21. First, multiply the first and last coefficients. So 2 times negative 21 gives us negative 42. Now, here's the puzzle. What two numbers multiply to negative 42 but add up to our middle number, 11? After a little thought, you'll find it's 14 and negative 3. We use those two numbers to split that middle term, we pop all 4 terms into the box, and then we just pull out the greatest common factors from each row and column. And like magic, the answer just appears right on the outside.
But what if you want to go even faster?
like lightning fast. Well, for simpler problems, there's this incredible mental math technique from Vedic mathematics that can give you the answer almost instantly.
Okay, just look at this. X squared plus 7x plus 10. All you got to do is find two numbers that add up to the middle number, 7, and multiply to get the last number, 10. A quick mental check. Yep, it's 5 and 2. And that's it. The factors are just x plus 5 and x plus 2. Boom. It's so efficient for the right kind of problem.
All right, so we've got our algebraic toolkit all packed. Now let's get back to our first riddle and see how all this abstract math stuff actually builds the world we live in, from secret codes to skyscrapers.
This slide right here just nails the whole concept of digital security. Factoring 15? Easy. You and I could do it in a second. It's 3 times 5. But factoring a 600-digit number that's the product of two gigantic prime numbers? Forget about it. It's practically impossible, even for the most powerful supercomputers on Earth. That huge gap in difficulty is the lock on your digital life.
And believe me, it does not stop there. In finance, analysts are constantly factoring complex market data to isolate the key drivers of risk and growth. In construction and architecture, factoring the dimensions of a building lets you optimize how you use materials, making sure everything is efficient and structurally sound. It's everywhere.
And how about AI? There's this wild concept called matrix factorization, and it is literally the engine behind the recommendation systems you use every single day. The core idea is that it breaks down this giant, messy spreadsheet of all users and all items into two much smaller, simpler ones. One describes user tastes, the other describes item features. By multiplying them back together, services like Netflix and Spotify can make a really good guess about what you're going to want to watch or listen to next.
Now, of course, it's not a perfect system. These AI models face some pretty big hurdles. Data sparsity, for example, just means most of us haven't rated most of the things out there. And the cold start problem? That's what happens when a brand new user signs up or a new movie comes out. The system has zero data to start with, so it's just guessing in the dark.
So think about the journey we just took. We went from the prime DNA of a single number all the way to the engines that power our digital lives and recommend our movies. Factorization really is the unseen engine of simplification and security.
It really makes you wonder, doesn't it? I mean, if this one simple idea, just breaking things down into their basic parts, has such a massive impact, what other simple, fundamental math rules are out there hiding in plain sight, secretly running the world around us?
Hey, if you enjoyed breaking things down with us today, help other people understand these building blocks of our world by liking, subscribing, and sharing this explainer. Thanks so much for watching.